So in this video, I'm going to replicate the examples shown in the PowerPoint in a separate video, or covered in a separate video. There were three examples here. We working with these local temporary tables, kind of fictitious data, small scale data to illustrate how these join types work and how they return different output depending on the join type. So we reviewed an inner join, a full join, and a left or a right join. Notice that we had these two tables. The left table was our loan info temporary table, and then the right table was our vehicle make. And so these queries will ultimately appear in the script I'm about to jump to. So let's go there. I'm going to use the create table statement. I'm going to create a local temporary table, loan info. Recall local temporary table is only accessible for the session in which it was created. And then it will also be deleted or released from memory once I close this session. So literally once I close out of here or otherwise disconnect. So we're going to create this table. We're going to supply fields, three fields: account number, loan amount, and loan term. The account number field is defined as an integer field. It's also going to be defined as a primary key. The loan amount second field is going to be defined as a float. So that's a numeric data type that can accept decimal precision. And then our loan term field is ultimately going to be an integer data type. So I'm going to create that table. If I were to select all fields from that table, you would see these three fields listed with no records. So we're going to give that table records now with an insert into statement. So we're going to insert records into this table. Using the values statement, we're going to supply values directly. This is comparable, for example, to SAS's data lines. And we will basically supply a value for the first record of 1 for account number, $13,398.66 for the loan amount column, and then a loan term of 36. And we'll ultimately supply four records. So we'll do that. And then we will select that all fields, all records from that temporary table. And so when we do that, we can see that this output here matches the output shown in the PowerPoint example for this table, right? So we have 1, 2, 3, 5. We have 1, 2, 3, 5. The loan amounts are the same, 36, 39, 60, 48, right? So those all match. And we'll do the same for the vehicle make table. I won't, the other temporary table, which will be our right table in all our examples. We have two columns. The second is a character field defined that accepts up to 12 characters. So we'll create that table. We'll insert data into it through the values statement, and then we'll select that data, right? And so this is the same data ultimately that appears also in the PowerPoint. 1, 3, 4, 5, Toyota, Ford, and Tesla, right? So going to our inner join example, we have our we're selecting all fields from loan info is our left table with a table alias of A. We're performing an inner join with a vehicle make as our right table with a table alias of B. And we're ultimately joining on the field's account number between both tables. And we're going to order the output by the account number in the left table, table A. And so let's run this query. We'll see ultimately that the output is the same as what is included in the PowerPoint. And that's going to be the case for all of these. I'm not gonna go back to the PowerPoint just to prove it out. If you notice something that isn't the same, please let me know. But I've double checked this quite a bit. So let's just work with this example a little bit more. Let's just say we just want right a few fields. So how do we do that? So let's just say we want account number. Okay, we'll supply account number that we want that field returned. We can see that we start to get a syntax error. It's already displayed here nicely enough. So it's telling us that there's an ambiguous column name. Recall that this field exists in both tables, right? And so while a table alias isn't required, if it doesn't exist in more than one table, it is required in this case. So we want it from table A, let's say. At the end of the day, in an inner join, it's not going to matter because all values are returned or matched. And then let's say we want our loan term. Notice that I don't need a column alias for this, or a table alias rather, because it does not appear in, it only appears in the loan info table. And then let's also do vehicle make. Okay. And so we have, through this, we have, through our altering our select list, we have essentially altered the output from the join. And we see some of the information from the left table is joined to information from the right table. Now, I said best practice, always use table aliases, and I'm gonna make sure that we do that for that I hold true to my my mantra. But just to point out that it is possible. And this should be fine. I don't, oh, well, it won't be fine because that loan term table does not exist in table B, it exists in table A. So SQL is helping me out there. So the other thing I want to point out is this, the asterisk symbol, right? Our original select list was a select star. Well, what if which is all fields across two tables? Well, what if we want all fields from table A? That is simply a dot star. So we use the table alias A, and then all fields from table A. And so if we do that, we'll get three fields, right? Three fields from A. Well, what if we want, a field from table B, the vehicle make field? Well, let's go ahead and add that to our select list. And notice that in the past, we've always kind of included in a single table query, included the asterisk symbol by itself, but that can be one item in multiple items in a select list. So you can have more items, add more items to the select list. And so if we do that, we'll see that we essentially added information from table B in addition to all fields from table A. The other thing that I'll point out is I believe if I remove this order by, I'm just going to do that, just kind of reinforcing that concept that we can add additional items with the asterisk symbol. Right? This should execute fine. We're just going to get a lot of replicated columns. We're going to get all columns from table A, or all fields from table A, all fields across both tables, all fields from table B, and then a field specifically from table B. So this is going to explode out, right? The reason I commented out the order by clause, which going back to that example, is that we've essentially replicated, we have the same column name for a lot of these fields in here, which if we weren't to be explicit about which column alias we wanted, we would end up getting an error. And even in this case, I think we're still going to get an error because I could be wrong. Actually, no, we won't, because this doesn't refer to the select list. This is referring to the field within the loan info table. So this will execute fine. But we'll just return it back to its normal state. I do want to point out without a table alias, the error is returned here because we have both column field names in the output, right? And so we get an ambiguous column name error. So I'll briefly run through the other examples because they're not as we've kind of covered what I wanted to cover with the table alias and how to alter the select list, and then also about ambiguous columns. So with the full join, note that the output will match what we have in our PowerPoint. And then this was to prove out that the output is shown as reflected in the output without an order by. It does go down sequentially, account number 1, 2, 3, and then it goes to account number 4 over here, and then account number 5. If we introduce the order by, right, the null value so what's record 4 now, will display first because that value for account number in table A, when account number in table B is 4, that value is null. And so that will ultimately be how the output is altered. Now I'm going to re-execute this. I do want to point out a few things. How would we identify records that are unmatched in table, let's just say in table B? They appear in table A, but they don't appear in table B. Well, we can do that with a where clause. So let's just say where B account number is null. That means the account number does not appear in table B, but it appears in table A. And so from this output, by restricting the output to just unmatched values from table B, we'll see the second record returned, right? And so this tells us, okay, we don't have a match in table B for account number 2. We can do the same thing, for unmatched values in table A. And so this is really with a full join. And so we can see, okay, account number 4 appears in table B, but it does not appear in table A, or the left table. And then, so one of the things that comes up, right, is if you're looking at both of these queries, or both of the output from these queries, when you remove the where clause and you've got the unmatched records from both tables, right? There isn't a, right, if we just wanted to return one column for account number here, is not a great way to do it, right? If we return this one, we're still going to get a null value here. If we return this one, we're still going to get a null value here. And this is where the isNull function comes in handy, right? So if basically what we're going to do is if a account number is null, so if a value is null, so which this one will be, we're going to return instead the column B, table B account number. And so that, in this case, will be the value 4. So when we do that and return it with a column alias of account number, so the original column alias from the 2 tables, we'll see that the information is complete for that field. We've reduced that account number field that appeared twice in the output, both having null values, into one field that no longer has null values, but we can see null values here from table A, which means that this value appeared in table B, and then this vice versa for record, the second record. So just want to point out the isNull function come in handy for more than just altering the value of null output, but also creating new fields, right, that are kind of a match between two different fields where null values might occur. And then the left join and the right join. Just want to point out here, the left join can ultimately be rewritten as the right join. So this is a subset, right, of the full join. All the output or all the values in the left table, loan info, are displayed for table A. And then regardless if there's a match in table B. The matches the values for account number in table B, or the right table, that aren't found in table A are not included because this is a left join, not a full join. And so I just want to point out that this can be written as a right join by altering the order of the table names, right, in the join or in the from clause, and then also rewriting or changing left to right. In this particular query, so we'll see the same exact output between the two. I can run them simultaneously. Notice that I did keep table alias of A as the first for the left table, right? Even though the table's changed. You wouldn't ultimately need to do this. We could have kept this table alias B and this table alias A, in which case we would have needed to replicate, we would need A star and then B star, because if we don't do this, if we were to just do star, fields from this table, our left table, will appear first. And I'm just being pedantic because I'm just pointing out that in order to truly replicate the output, you have to order the elements within the select list to reflect the order that they would have appeared by in the original query. And that's why I was doing that here, not necessarily not necessary, obviously, because the output is still the same. And the main point is that a left join can be rewritten as a right join and vice versa. And then in this particular example, I'll just execute this to show that should return the same. And it didn't because I'm ordering, I didn't change this, the order by. Originally, I had switched the table aliases, then I switched them back as I was walking through the example here. So now we've replicated the results identically. And then I just want to point out that table aliases A and B, that's what I've been using. That's what you'll likely see, but you can ultimately supply different table alias names. Here I've used brackets. Brackets aren't required, right? In these particular for these particular table names. You could also use single quotation marks, right? Essentially everything we went through for didn't like that, which is a little bit surprising. Yeah, maybe you can't. I've eaten my words many times while working with SQL, so I shouldn't have said it so confidently. But so it looks like you need to use brackets, or I believe you'd be fine. Can't use single quotation marks as you could in the select list. I believe you probably could use double quotation marks, which I haven't talked about in this course. I never see this in practice, although I imagine some people do. But this would work as intended. We get that same output that we saw in the left join. And then, the point I was making here is that the account number field in the left table is going to be the one where there are no null values for account number. So if we were to, not accidentally, but say we supplied the make from the right table, this is a left join, we would get a null value here, all right, which for value 2 appears in the left table but not in the right, and so that's why the record is returned, but there is no value in the right table for account number for that particular account number. So that was to reinforce that you need ultimately a table alias here. From the left table for account number if you want all of those values to be displayed. And then I'll switch this back. I guess I can say something about double quotations. I've never seen it in practice, but they are ultimately reserved for objects. So you can do that with a table. You can do it with a field name as well, which I've seen some students do already, which is perfectly fine. I don't happen to see it in practice very often, which is why I don't really cover it. But just to point out that that's yet another option for aliases. And so that really concludes this lecture, where we kind of took a deeper dive on the examples from the PowerPoint, illustrating the inner join, the full outer join, the left and right outer joins, and then also some other small, new, more detailed kind of deep dives in terms of table aliases within the select list, column ambiguity, how table aliases can be different, etc.